So now let's return to where we were before. If you remember, we said that that very first day of class, we were looking for the slope of the line tangent to this circle at the ordered pair 4, 3. And here's another way we could have done this. We could have used, in fact, what we will call implicit differentiation. So keep in mind what we're looking for is dy dx. And rather than solving for y, here's what I'm going to do. I'm going to take this equation and I'm going to take the derivative of both sides with regard to x. And let's see what happens. Well, when I take the derivative of x squared, that's just going to be 2x. But when I take the derivative of this y squared term, what I need to do is assume that y is just some function of x. So when I take the derivative of y squared, that's going to give me 2y. That's the outer function. I'm just using the chain rule, but then I need to multiply by the derivative of whatever y is. On the other side of the equal sign, the derivative with regard to x of 25 is just 0. So let's just play with this a little bit. I need to isolate dy dx. So I'm going to move the 2x over, equals negative 2x, and I'm going to divide both sides by 2y. So I end up with dy dx is negative x over y, and now I know at the ordered pair 4, 3, my slope is going to be negative 4/3, which is exactly what we had gotten before. So let me show you another example. And basically, this is what we're given. We're looking for dy dx, and we have some equation. And it's really hard or impossible to isolate y, or you just don't feel like doing it. So what I'm going to do, this is on page 213 in the textbook, and I'm going to show you problem number 4. So this is cosine of x plus square root of y is equal to 5. The old way of doing it would have been to isolate y, which would have given us square root of y is 5 minus cosine of x. I'm going to square both sides, so y then would be 5 minus cosine x squared, and then I'd take the derivative. So dy dx is chain rule, take the derivative of the outside to the first, and then the derivative of cosine is negative sine, so the derivative of negative cosine is positive sine, so times sine of x. So that's dy dx. Let's also do that. So remember what that looks like. Let's also do this using implicit differentiation. So we'll try it a little bit differently. So here we have cosine x plus y to the 1/2 is equal to 5. I am just going to take the derivative with regard to x of both sides. Just plow from left to right. So on the left-hand side, the derivative of cosine is, and now I need to isolate dy dx. So I'm going to move the sine x to the other side. So basically I have 1 over 2 root y. dy dx is positive sine of x. And I'm going to, again, isolate dy dx. So I'm going to multiply both sides by 2 root y. So I get dy dx is 2 root y times sine of x. And let's just look back at what we had earlier. Because earlier we had 2, and here I have 2, right? So there's 2, sine of x, sine of x. Over here I have 5 minus cosine x, but over here I have 2 root y. But in fact, if you look at that, in fact, I have the 2. The root y is 5 minus cosine x. So I have the exact same answer, just in a slightly different form.